Back to Physics Unveiled. My name still remains Franklyn Einstein, and today we're talking about a very important topic, which is the electric flux and Gauss law. Now, electric flux. Now, let me explain before I go into the calculation and what have you. Now, electric flux. What do you understand by electric flux? In fact, the word flux, most students don't even understand the meaning of the word flux. Flux, in other words, in the simplest form, means strength. How strong this thing is because of the contact it has with a particular field. For example, now electric flux now means how much of an electric field is on a particular surface. That is what electric flux is. All right, so we're dealing with electric flux, and then we'll enter into the Gauss law. Now, to make everything very short for you guys, because of course this is Physics Unveiled, we summarize things bit by bit. And remember, if you have any question, you put it down on the comment section. So now, electric flux. Now, what's electric flux? Now, electric flux, we use psi as a symbol. Electric flux, we use psi, is equals to the electric field multiplied by the area. All right, the electric field, that's the area, a particular area, a plane, is coming in contact with. That is electric flux. Right, so this is the formula that you need to know about electric flux. Now, obviously, we've talked about electric field before, the last video of electric field, even in the theoretical aspect of electric field. So go ahead and go and watch those videos. Now, electric field now, we make use of what? Lines of forces, right? Lines of forces. So let's say it's an electric field, right? And then there are three cases now involved under flux now. If a material, all right, comes in contact with an electric field in different axes, for example, now, let's say a material comes in contact with an electric field perpendicularly. This is a material. It is perpendicular to the electric field. Electric field meets this material at angle 90 degrees. So it's perpendicular, right? The electric flux on this material, we also electric field times the area. This is very, very simple. All right, please, I want you guys to jot this thing down, have a note and jot all these things. Very important. So the case one is that whenever the surface area is in contact with the electric field perpendicularly at 90 degrees, the flux is given by the electric field multiplied by the surface area of that plane. Now, the second case is when this material is parallel to the electric field. The material is parallel to the electric field. In this case, right, there is no lines of forces or electric line of forces on the material itself, right? So therefore, the electric field on the surface is zero. So therefore, the flux will be equal to 0 times the area. That will give us 0. I forgot to tell you guys, the unit for electric flux will be what? Now remember, area is in what? Meter squared, right? Electric field is in what? Newton per coulomb, right? So Newton per coulomb multiplied by meter squared, we have Newton meter squared per coulomb. So this is the unit for what? Electric flux. Please don't forget, jot that down. So whenever the material is parallel to the electric field, the electric flux is 0 in all questions, right? In all questions. Now, the last one is when the material makes an angle with the electric field. The electric flux becomes electric field multiplied by the area, then cosine the angle made or the angle formed, right? So this is what you need to know about electric flux. Electric flux is the product of electric field and the area. Then in the case where in equation, where you say the material is perpendicular to the electric field, this is just the equation you use, the normal equation for electric flux. Parallel to the electric field is always 0. Then it makes an angle of 50 degrees, 30 degrees, 60 degrees. This is this equation here. I'm sure you guys understand. So now let's go on into solving few questions so we can see what I really mean. You can understand this electric flux better. So let's just take a few examples. So example 1. The first question say at each point on the flat rectangular surface 10 cm by 20 cm, the electric field has a magnitude of 200 Newton per coulomb and makes an angle of 60 degrees. Calculate the electric flux for the surface. Of course, now let's solve this now. So solution, right? The first step, parameters, right? So at each point on a flat rectangular surface. So now they're giving us the shape, right, of that surface area, right? 10 cm by 20 cm. Obviously, in rectangle, 20 cm will be the length because it's the bigger one, and 10 cm will be the what? Be the breadth, right? So the electric field of magnitude, this electric field is what? 200 Newton per coulomb and makes an angle of 60 degrees. Now, this surface area makes an angle of 60 degrees, right? It makes an angle. So remember the formula we use, right? So now, electric flux, when a particular surface makes an angle, it's electric field times the area times cos the angle. So we have an electric field, right? We have our angle. Now the area, how to find the area? They give us the shape is a rectangle. Now what's the area for a rectangle? The area for a rectangle is what? Length times what? Breadth. Am I right? Am I right? Good. So now let's convert this to meter and then find it. So for length, 20 cm to meter with 20 divided by 100, right? And that will be, let's say 20 divided by 100. So this is now for meter, right? Then the breadth will be what? 10 divided by 100. Are you confused? Now what I'm looking at, this 20 cm is in centimeter. I have to convert it to meter. I will 20 divided by 100. So this is in meter, alright? Times this 10 cm too is in cm. I have to convert it to meter. So it's 10 cm over 100 cm, alright? Goes like that. So now if you do it, what we'll be having? We'll be having 2 over 10 times 1 over 10, and that will be 0. What? 0.2 meter squared. Right? So this is the area. So we have the area now. Let's input the area into here. So electric flux, because electric field is what? 200 multiplied by what is our area? 0.02. Then cos, what is cos 60? Am I right? So now if you do everything, you should be having this times this 100 2, right? 2 Newton meter squared. Am I right? Yes, I should. Right. So this is the answer for this question. That easy as that. So they may give you the shape itself. It can be a rectangle, a triangle, or whatever the shape is. You have to find the area from the shape and impute your whatever. So let's look at another example so we can see what we are really saying. So let's go to example 2. A circular plate has a radius of 7 centimeters. The plane of the plate is set at a 60 degrees angle to a uniform electric field E equals to 355 I Newton per coulomb. Calculate the flux through the plate. Very simple. So this is solution, right? A circular plate. They have given us the shape now, so we can find the area of that. Has a radius. So a circular plate. So the area of the side is what? Pi r square, right? So I say it has a radius of what? 7 cm. 7 cm. So you convert cm to meter. So you divide by 100, right? And now you use 0.07 meter. Now the plane of the plate is set at a 60 degrees angle. So our theta is 60 degrees. So uniform electric field E equals 355 I Newton per coulomb. Calculate the flux through the plate. Now let's understand few things. Now this electric field now is in a vector form. But you don't need to use the vector form in this question. You need to use the scalar form, right? You should have only magnitude. This is just a direction, right? So to remove this, you can just go ahead and saying the answer is E equals to 355 Newton per coulomb. Right? This is the answer actually. But what if we have two directions, I and J? The best way to find the magnitude is this. You put this in all E direction, I, J, and K. So E actually is 355 I plus 0 J plus 0 K. This is E actually. Okay? This is E actually. So Newton per coulomb. So to find the magnitude of E, right? That will be the square root of the component, the coefficients of the component, their square. That will be 355 squared plus 0 squared plus 0 squared. And this is because of the square root of 0 squared plus 0 squared, just 0. 0 plus this is just this. The answer will be 355 all squared. And if you do that, you will still be having what? 355 Newton per coulomb. Now the I is gone. The reason why I did it like this is so that you won't make the mistake. What if your E actually is 355I plus 300J? Then this is how you actually get the magnitude, right? So since it's only one direction given, the answer is just that same magnitude. All right, so we have electric field now. Let's go over and get in our area, right? Because electric flux obviously is equal to electric field times area. Because there's an angle given, that will be cos what? 60 degrees. So now our area of the cycle is pi r square, right? That is pi. What is our r? Our r is 0.07 all squared. You get, and if you do that, you should have something like 0. This square is 0.15, I think so, 4 meters squared. So our area is 0.0154 meters squared, right? So putting this area into this, we have that flux is equal to electric field is 355 times our area is 0.0154 multiplied by cos 60, and everything should give you 2.735, right? Am I correct? 2.7335 Newton meter square per coulomb. And this is your final answer of electric flux. So electric flux, you might see the shape there. So the shape is given to you, so you can find the area, right? So solve for rectangle, you solve for cycle. Now they might give you a question whereby the shape is not given to you. If the shape is not given to you, they must give you the area of that whatever. Since they didn't say rectangular or circular or triangular, they will surely give you the area, because you can't find the area of an unknown shape, right? So let's go over and solving another question so we can understand it better. So let's go to question 3 now. Next question is: a flat plate having an area of 5 meters squared is rotated in a uniform electric field whose magnitude is 7.4 times 10 to the power of 5 Newton per coulomb. Calculate the electric flux through this area when the electric field is I perpendicular to the surface of the plate, II is parallel to the surface, and 3 is makes an angle of 75 degrees with the plane of the surface. It's very simple because this is one of the cases we just mentioned, right? So solution for number 1, obviously we have what? An area, because the shape was not given. Say a flat plate. Is it a circular one, a rectangular one, a triangle one? We don't know, so they give us the area. As I've told you, if they didn't give you the shape, they must give you the area. So that's the area. So the area is what? 5 meters squared, right? And rotated electric field at 7.4 times 10 to the power what? 5 Newton per coulomb. Calculate the electric flux. Okay, so electric flux what I'm looking for. Alright, so for I, perpendicular, the case 1, when it's perpendicular, the flux is just equals to E times A, electric field times the area. And then if you do that, that will give you 7.4 times 10 to the power 5 times 20 area 5, right? And when you point that, you have something like 37.0 times 10 to the power 5 Newton meter square per coulomb. And that is all for the first question, right? Now moving on to the second one. They say it's parallel to the surface. When it's parallel to the surface, meaning that the electric field did not have any contact with what? These plates, alright? So the area, so the electric field on this plate is 0. So for 2, electric flux is equals to 0 times area. There was no electric field, there was no electric field lines on the flat plate because it's parallel to, it's flowing with the same direction as the what electric field lines. So there's no contact, so it's 0. So the flux will be 0 Newton meter square per coulomb. Nice. All. Now for the third one, it makes an angle, right? So the flat plate now have tilted from an angle of what? 75 degrees. So our flux now because electric field times area and the cosine of that angle formed. Alright, so that's electric flux because to, okay, this electric field times area is just this, right? So we have 37 times 10 to the power 5, then multiply by cos. What is the angle that's formed? 75 degrees. So if you do that, you have like 9.58 times 10 to the power 5 Newton meter squared. And that is the answer for this. So you can see this question where we use the cases, alright? The case 1 just perpendicular, that is just electric flux, the formula for electric flux, electric field times the area. Solve it. When it's parallel, electric flux is 0. Now when it makes an angle, you use the electric field times area times the cosine of the angle being formed. And this is almost everything you need to know about electric flux. It's very, very simple, alright? So when asked you to what the formula for electric flux is, electric field times area. Alright, so let's go into one last thing, which is the Gauss law, because the Gauss law relates this electric field with other things. And what is that other things? Relate electric field with charges. Alright, so let's go into knowing what Gauss law is all about, and then let's see what we can do about. So Gauss law now. See this word Gauss law states, alright? Now I'm showing you how to write this in your test. In your test, they'll ask you state Gauss law. First of all, write Gauss law state that the surface integral of the normal component of an electric field through any closed surface containing a total charge Q is Q over epsilon naught, or we call it the permittivity of free space. Now let me tell you this one thing. In your test, if you're asked to state a particular law, most law you'll be asked to state in physics always comes with an equation. Make sure you write that equation. Even though in a test hall where they say time up and probably you cannot finish up, right, of time, instead of writing this long thing, can we write Gauss law state that, then go into the mathematical form and write it. That way is better, right? So please, whenever you write law in physics, put the mathematical form. Now what's the mathematical form of this Gauss law? It's very simple. So the surface integral of this normal component. So mathematical is written as this. Writing this this law, write mathematically underneath, mathematically, all right? So this is the surface integral, all right, of the electric field, and this whole integral is actually known as the electric flux, and this is equals to the total charge, the net charge over the permittivity of free space. Right, so this is the whole of Gauss law. State Gauss law in your test, write all these things and got in your full mark, and you passed. Then A. So this is all about Gauss law. So what this tells us that flux now has two formula: electric field times area, and also has another formula, the total charge over the permittivity of free space. Alright, so in a question, they can ask you to find the electric field or the area, and I'll give you the charge and other things. Then use these equations to solve electric flux. So this is electric flux, electric field times area, electric flux, and then charge, the net charge or total charge over what's permittivity of free space is also electric flux. So this is what Gauss law states. So write it down in your book, memorize it. There are funny ways in memorizing things for a test. There are funny ways. All the ways that you can take off a book. In case the test is very, very close, you stand up or sit down, you stand up, then you start memorizing. Memorize bit by bit. The surface integral of the number. You repeat it several times. Repeat these three lines several times. Get the formula. This example, and you pass. There's no need for doing malpractice. There's no need of you carrying paper to example or carrying phones to the example. There's no need. It's just for you to practice. You don't have time to practice, you should have time to practice. Alright? Or you can just watch more of my videos. It will tell you everything to know about your tests and even your exams. Also join the WhatsApp channel where we'll see more questions, theoretical questions to solve. And I promise you'll get an A in physics. So let's go into solving few questions on that Gauss law so we can understand it better. So let's go into the first question. First question, it said the net flux out of a cylindrical enclosure is 3.14 Newton meter square per coulomb. What is the charge enclosed by the cylinder? So write a solution, right? You got the flux, right? So the flux is 3.14 Newton meter square per coulomb. What's its charge? That charge, right? That charge. So what equation relates flux with total charge? Gauss law. So in your test now you write from Gauss law, right? From Gauss law, flux is equals to total charge or divided by the permittivity of free space. And now mind you, this permittivity of free space has its own value. Permittivity of free space is equals to 8.85 times 10 to the power of negative 12 was unit farad per meter. Alright, get now farad. What is the farad? Is unit for what? Capacitance. Now we'll get capacitance. So this is what you just need to solve this question. So I have to find the net charge, right? So you make the net charge the subject what's formula and you do that by cross multiplying. So therefore our net charge will be equals to the flux multiplied by the permittivity of what? Free space. Now what is flux? 3.14. Permittivity of free space is what? 8.85 times 10 to the power of negative 12. And when you multiply that, you're having 2.7789 times 10 to the power of negative 11 coulomb. Right? Point that calculator and confirm the answer. So this is how to solve this kind of question. This is just Gauss law. As simple as that. You have flux, you have your charge. When you have your flux, find the electric field and what have you. But in Gauss law, strictly for Gauss law, something about charge must be related. Alright? That didn't know about Gauss law and just solving normal electric flux. Electric flux, charge may not be in the question, but for Gauss law, when you know to use Gauss law is when you see something like charge in the question. Alright? So how to find charge in this one? Charge may be given to you to find any other thing. So let's go on to another question so you can see what we are talking about. So question 2 now. Question says 3 charges each of magnitude 2.95 microcoulomb are enclosed in a box. What is the net flux leaving the box? 3 charges each. So you have 3 charges. Each of them has what? 2.95 microcoulomb. Right? So now solution. The net charge now the net charge is the sum of all the charges, Q1 plus Q2 plus Q3. Alright, but since each of them has the same magnitude, this should just be equal to 3 times the charge here, which is equal to 3. What the charge? 2.95 microcoulomb. Alright, that will give you 8.85 microcoulomb. For microcoulomb is not the unit for what? Charge. So change to coulomb, that will be 8.85. Micro is times 10 to the power what? -6 coulomb. Do you understand? So we have to find the what? The net flux. Now flux, right? But from Gauss law, flux is equal to the net charge, right, divided by what? Permittivity of what? Free space. So write from Gauss law. This is just for the test. For example, can just go straight. Alright. So therefore, the flux is equal to what? The net charge, 8.85 times 10 to the power what? -6, right? Divided by what is the value for permittivity of free space? 8.85 times 10 to the power what? -12, and that will be 1.0 times 10 to the power what? 6 Newton meter square per coulomb. Alright, so this is very simple. So we have 3 charges. If those charges are unequal, separate charges, you sum all of them together. But since they are equal, it will be 3 times the charge that is there. Alright, so this is how to solve this calculation. So as you can see in Gauss law, charge must somehow be present in the question. So anytime you see charge, you see flux, what will come to your mind is what? Gauss law. Alright, his full name is Carl Friedrich Gauss. That is full name. One of the greatest mathematician and physicists we were expecting so much in physics because he did a lot of work. Even what we call the Gaussian surface, how the Gaussian integral, and so on. So Gauss is a very great man. So he helps us understand this very well. Gauss is just an extension of Coulomb's law, right? Gauss law is to solve difficult problems that Coulomb's law can't help us to solve. Alright, so let's go into the next question and see what we can use Gauss law to solve now. So question 3. Question says, what is the area of a conducting plane sheet if the electric field to the plane is 400 Newton per coulomb and the charge contained by the sheet is 50 times 10 to the power -9 coulomb? So the Gauss charge, so Gauss law comes to your head. Alright, so solution, what is the area? I have to find the area, right, of a conducting plane sheet with electric field. So get the electric field as what? 400 Newton per coulomb, and the charge, net charge, that's what? 50 times 10 to the power -9. To find area, because electric field, to find area. Now I know electric flux is equal to electric field times area, but flux was not given, right? But I also know from Gauss law that flux is equal to the net charge over the permittivity of free space. So since this is flux, this is equal to electric field times area. Alright, so if you cross multiply, you should have electric field times the area multiplied by permittivity of free space is equal to the net charge. Alright, since area is what I have to look for, you divide both sides by what? Electric field and permittivity of free space. Electric field and permittivity of free space. So you can cancel that from here. Alright, so area equals to net charge divided by what? Electric field times permittivity of what? Free space. So you impute your values. What are net charge? 50 times 10 to the power of -9, or divide one electric field 400 times Amplitude of free space is what? 8.85 times 10 to the power of negative 12, right? So our area will be equal to 50 times 10 to the power of negative 9, and 400 multiplied by this is approximately 3.54 times 10 to the power of negative 9 itself. So when you divide that, our area should be something like 14.12 meter squared. 14.12 meter squared. And now the final answer. You see, so flux was not given in the question. But we know what flux is. Flux has two equations. Firstly, flux is equal to electric field times area, and flux from Gauss law is equal to what? The total charge or net charge divided by what? The permittivity of free space. So you can get any of that through these two equations. I'm sure you understand. So this is what you need to know about Gauss law. For this is everything about Gauss law. In our next video, we'll be discussing about the application of Gauss law, where you meet questions like using surface charge density, linear charge density, and so on and so forth. All right, so you keep watching. Please like and subscribe. It is very important. When you subscribe, anytime a new video comes in, you get to be notified, right? So you can watch everything, right, from capacitance to potential to Kirchhoff law. Those things are all very simple. You don't need to be scared about this semester. It's going to go very well. All right, so I still remain Franklyn Einstein, and I'll see you in the next video.